I want to go through the mini code hand tracker. In case you didn't see it when I was running, let me try and run it again. Okay, I need to pull this back in first. So try and pull it. Set this back in. Okay. So I'm gonna make it run. And it's not supposed to see my mouse. My mouse just looks like a hand. So this is it here. So it's basically just a minimized or minimal code for hand detection. As you can see, you can detect my hands. And if you can count, you draw it like if you have a time to count, you see that actually 21 points. And it's written in the code. I'm going to check it out in the readme file over there. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, and it's always 21. Pardon me. So stop this. So let me show you where it's 21 or where we said it's 21. So these are the connections here. So you see with let me just show it again. But it's mapped out here. The connections are mapped out here. Then the interconnection is done within one now. But as you can see here, from 0 to 5, 0 is connected to 1, and then 1 is connected to 2, and then 2 is connected to 3, and then 3 is connected to 4. Just over here, right? So same thing now. 0 now go connect to 5, 5 will connect to 6, will connect to 7, so will connect to 8, and then 5 will go and connect. Stop showing or not? Stop showing. Okay. So and then now 5 will connect to 9, and you get a picture. So that explains just a little part. The other parts we're working on that. Let's go through the readme. So now, if you can get me, I'll be so funny. Why is it funny? It's so embarrassing if after all this explanation does not, I realize that I was speaking up. Let me make sure it's my mic. Okay. Yeah, I believe my mic's okay. I don't know whether you can hear me, but I just pray it's okay. Alright, so okay. So media pipeline. Hand tracking with OpenCV. So I was following a how can I say it, a free course or what? A computer vision course, advanced computer vision course from freecodecamp.org on YouTube. But that video was 25 years ago. So I had to check whether it will be applicable today, and like I suspected it is not applicable today. So following through some documents and the updates on MediaPipe, I was able to get this guy. This spider is almost 100 it's almost 200 lines of code due to the fact that I put a lot of spacing and exponential in between. But it works cleanly, and so let's see right. So the original course code used the older MP solutions .hand API, but the project instead uses this task. So this task basically makes rather MediaPipe introduce tasks. Tasks can call different models. What are models? These are the various models. There's a face landmark model, there's a gesture recognizer, there's a hand landmark, and there's a pose landmark. So for this video that is just for hand tracking, you just need the hand landmark, because MediaPipe will automatically recognize a hand, and now using the hand landmark to point out 21 points across our hand whenever it processes from OpenCV. So how does it do that though? What this project does: application hosts the computer webcam using OpenCV, captures video frames continuously, converts each frame, converts the frame into MediaPipe image. Let me just point out this. So first of all, Opus computer webcam using OpenCV. So just about a video. Do you need these guys? Oh, my colleagues. So therefore, I didn't need this. So basically, you need this guy OpenCV, media by this for the hand tracking, this for the hand tracking, also this hand tracking. Import time was not really used, but yeah, it was not really used. And then from Matlib, Matlib is basically because my path were a little bit different. If you get to bundle everything, that is the models and the scripts and the video analytic, it's around project. Then you will need this path module. I basically use this path module from Matlib import path because I placed the script in one folder and then the models in another one. Reason being that I didn't want to have all the models and the script in one folder. Why do you ask? Or why did I do that stupid thing? Because if I want to put different projects in this directory, which I would eventually, because we're going to be doing other advanced computer vision projects in this very directory, then I want to separate each script, and I want each script to just call either of these models, whether it be face, landmarker, or gesture, whichever one. So I want all of them to be here. But if you want to make a separate project just dedicated to one or all of the models, then you can go away with just having the models and script in one folder, in one directory, and then you don't need to call them this long way. Because basically what happens here is that this base directory is going to get the base directory or the main directory, this directory, from roots. Because I'm using Linux, I'm using Windows from I think it's Drive C or what. But this base directory is going to take from roots to user to right up to this advanced computer vision folder, and then it's going to attach now the remaining pathway to get to this hand landmarker model, which is over here. I don't know which is coming to get it, which is over here. Okay, so that's it is really adding complexity on the reason, but eventually subsequently we'll go to other projects. You'll see that it's just going to be a lot more efficient, especially when you have to call all different models and having them each model inside the folder. For me, that's like having duplications for no reason. Okay, so next, where were we? So first of all, opens the computer webcam. So what does this opening? We'll scroll down a little bit. We'll come back to this other guys later, don't worry. So this is the open webcam. So in order to open the webcam using OpenCV, you're going to call a variable called cam. We're going to put equals to cv2.video capture 0. The video capture 0 is typically the main camera on your laptop or desktop. That's the one camera. If you add another camera like me right now, this video of myself you're watching is on cam 1 to cam 1, then you direct to this camera. But you need to make sure that the camera is free. For example, cam 1, which is this phone where you're seeing it right now, is in use, and therefore this error here will actually be triggered because the camera is not accessible. Cam 1 is not accessible, but cam 0 is accessible, so we will not go through this error. So basically I kind of explained this guy there is a set of error management in case camera does not open or is in use. So it's going to just print error, camera is going to exit, it's all good. Timestamp 0, we're going to use timestamp subsequently because one of the modules needs an argument of the time. Okay, so we're going to main loop, but let's get back here. Captures video frames continuously. So that's why it's a wide through. So basically, if you don't put this wide through, it's just going to capture one frame and it's going to stop. Tell me like, okay, you told me to open the camera, put the camera once, that's it. But when you put wide through, it's going to just continuously be picking up the frames. So in order to pick up frames, we need to put success and frame. Success just checks and make sure that the camera is actually open and it can receive frames from the camera, and then frames are the actual frames from the camera. So check if you receive frames from the camera with an error. So if success is false, if success is not false, error will not be read. Okay, if not success, that is if not true. So if this is not true, it's going to be if it is true, they will skip this. So as you skip this, remember a mirror or like a camera, if you snap it, it's going to like mirror it. So we're going to flip it back so that it looks like a mirror. I don't know what I explain this sense about that. Basically, this following is going to just flip the frames horizontally because we want it to behave like a mirror. Oh, okay, because like a mirror, I think it's easier to like get it on understanding. Like if you view yourself back, you know, okay, this is left, this is right. Just like a mirror, right? Yeah, but if you put in just a camera on what your left becomes right now, it becomes left. Okay. Pardon me. Next one, convert each frame from OpenCV BGR format to RBG. Why does it do that? Explains it here because OpenCV uses BGR, that's blue, green, red colors, but MediaPipe expects red, green, blue color. So this RGB frame is basically going to convert the BGR to RGB, which is what MediaPipe converts. So OpenCV just records the frames and now sends it to MediaPipe. In order to send it to MediaPipe, you need to make sure that it has a correct format that MediaPipe can use, which means correct color and correct frame rate, correct format, all that. So we're also going to collect the frame into MediaPipe images. So this is it done here. Then timestamp. Normally here we just use time. Yeah, that's why important time. But you can get away with just incrementing the timestamp at every loop, since the loops are extremely fast. I'll talk about that's milliseconds or so. So now this is where we're going to run the hand detection. So this here is a module, and let's check out what MB image and timestamp. What are you seeing? Let's scroll down. This is the overall pipeline what I was explaining. The webcam OpenCV video capture gets the images in BGR. Then will convert the BGR to RGB. MediaPipe obtains the images. The handler maker runs hand detection and then places landmarks on the hand, converts the normalized coordinates into pixels. That is the coordinates, like what you saw again when I run it, is that it showed the points. Now those points are not like on the air, they're actually on the images, which it pinpoints for accuracy, and now it has to convert it back into pixels, because pixels is what the images or the views how they look like. So it's going to convert those coordinates, the X and Y coordinates, into the space on the pixels. That's on the camera, on the output video, how it's going to look like. Okay, and finally OpenCV draw is now going to draw. Sorry, I'm having a cough. So it's going to draw it on the OpenCV overlay as you saw there, and they're going to display that. Okay. So project structure, you can have a rather complex structure for now. Require packages, yeah. Media pipeline, imported that. One media provides multiple imports, yeah. That's mainly Google, because they kept updating, and now and I'm just having MediaPipe and OpenCV. Now you need to download the various stacks or the various models and all that. Then you must have a good reason to have updated your package. So now Python. So Python provides Python specific MediaPipe task functionality. For example, Python based option is used to configure the model. Okay, so that's why we have this guy. So this one is basically used to configure the model, or rather to just tell MediaPipe where to obtain its model. Again, remember we have a model for hand detection, we have a model for face detection, we have a model for posture detection. All of that is segregated. So the base option is just there. Base option, or rather this guy in Python is used to call this guy. Base option, which is used to point to the model. Why did he just point it directly? That's just some genius stuff. We're not allowed to know. So what about vision? What's vision there for? Vision provides computer vision tasks. Okay, like the handler marker and the handler marker options. And also running mode video. So basically how the model actually works. Also the options that the model provides. All of that is form mode. The home journals are all understood and interpreted through this module, because your Python ITE will get a hard time knowing what each model does, not do it as these are just really done. So rather we imported the module rather, for this guy who is going to read our models, and other hand with that you'll be able to interpret and know the options and the models you use and how you're going to use them. Okay. finding a model. My bad. So I explain how we'll get to this base, and then the model that we used was the hand marker task. The way I this result, okay, I also explain how to get this. So building the model path within is just very complex stuff for no good reason, because if you just place the model and the script in the same folder, you don't need to do this. Base options, okay, so yeah, base position, first media pipe configuration is this. Base option contains configuration that is common to media pipe tags. For example, this input argument is the asset path of the model asset path. So it tells media pipe where the train model is located. So computer vision is still under AI, and so it's showing some system models. Yeah, because media pipe expects a straight path. So without this, we'll be able to get some 6 paths. Actually got this error, so I had to search it. So understand that the model expects the path in the string format, not anything else. So and landmark options. Okay, this is here. So why do we have this? Let me explain it. This configures how the hand landmarker should operate. Okay, I told you. So it just basically the vision which we are taken from up here is able to rate the hand marker model, and it's going to interpret what it's going to do, what are the attributes or the arguments in it, all of that. So that's what the option is for. Just basically going to understand how you're going to operate and better explain to the IDE and some writer IDE like PyCharm how to use this module. So base options. Provides different running modes. Oh, okay. So the different running modes. Yeah, okay. Yeah, these options. So you could have just get this and here directly. That's defined running mode. So the vision running mode. The activity is image video live stream. I wonder what live stream does, but for now we use video. I wonder why we didn't use live stream. Okay, we're going to explain image used for processing video images. Useful for photographs, individual files, one-off analysis. Okay. Then video used for processing a sequence of frames like OpenCV, because OpenCV actually gets frames every I think it's 100 milliseconds. It's actually frames in videos. Just like okay, so you attaches them and plays them so fast. Like basically videos, and that's what videos are basically frames when very fast speed. But it's basically frames. Like videos that are actually attached images, but that are really long. We're talking about million frames shown per second. Am I sure it's in a million? Don't quote me on that. So video. So we're using the video running mode. We're basically into that we are processing sequence of frames, just like what OpenCV sends to media pipe. So this is appropriate for webcam processing, where we explicitly provide timestamps. Okay. Again, that's what we're using time. Designed for asynchronous real-time streams, so it uses a fallback mechanism rather than simply returning a result from every detection ball. For this beginner project, every day is easier to understand. Okay, well, once I hear about callback mechanism, it gets a little complicated. We'll get there eventually. So, number of hands too. This tells me that by the maximum number of hands. Okay, that's why he was able to show. So if I say this one, you will only be able to detect one. If I had 4 hands, but I don't, you only take the first 2 you see. So if I move one, you see the other guys. So there you get everything. So for example, 1 means detect at most 1 hand. Means detect at most 2 hands. This does not mean media pipe will always find 2 hands. If only one is visible, only one hand is returned. Easy to understand. Creating a hand marker. So the actual media pipe task is created with this guy. So this guy, what does he do? The with statement is useful because media pipe may allocate resources internally. How is that? When the bug finishes, those resources can be cleaned up automatically or conceptually. After you create this handler marker options, create from options. Okay, so this guy is going to make use of these options to create them for the vision. Now vision is just there to like interpret what handler marker can do and going to send to the ITA. So handler marker is going to be now deployed with the options that we defined, and I can detect the frames. Where are the frames into the CV video? That's why you see that indented, and that's why you see there's this column here because it's going to now extract the frames from over here down. So opening the webcam. Okay, if I explain this, yeah, there's always a built-in default webcam. So go come back, take camera, explain this. So this one checks whether the webcam is up and running. It's not there, off. And this is important because without this check, the program could continue even though the frames are being captured. No frames are being captured, and that's bad because it actually needs the frames. So there are no frames. So yeah, just working with the death of crashing codes. So reading frames down, success and frame. So capture the rate attempts to capture one frame. It returns two values, success and the frame. So every time it captures the frames, it returns true. So a frame true, frame true, frame true, the one that true frame. So true means frame was successfully captured. False means OpenCV could not obtain the frame. So the actual image OpenCV normally presents it as a numpy array. Okay, how really is it? I don't really want to get into this numpy array myself. Don't want that. For example, don't want that. Okay. For example, this how it looks like. Right with the channel. The channel represents blue, green, red. Flipping the webcam. Second mirror means horizontal flipping. Okay. So I believe maybe 2 means vertical flipping. I don't know. And then we put frame there because it's going to what is going to flip frame. It's going to flip horizontal vertically with one also. It makes the webcam be more like a mirror. That's cool. So the original camera, the left becomes your right. I explained it here, right? And after flip, the right, your left. So after a mirror, this left will be your left mirror on the camera, and this will be your right on the camera. Make the introduce normal camera, the left your right, and right your left. So this is required for obviously required just like this type of reference. So you can remove that. And now this conversion I explained it because media pipe expects this, but OpenCV says this, so you copy that. Creating media pipe image. So next OpenCV gives us a numpy array. Media pipe tags API expects a media pipe image array. So therefore we convert the OpenCV image to an MP image and send it to the media pipe task. So this is the image format, blah 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 blah. The data is GB frame. Okay. Now let's get into the juice of this. Visual display, image formats, data, okay, timestamp, media pipe requires a timestamp. That's okay, explain this. That's actually timestamp will actually be using time. This is much more better. This can provide a work of timestamp. That's all I'm time is running the hand detector. So the actual inference occurs here. Yep, just like explains. Wait. most important property of this project is results dot hand landmarks. So the most important is this guy, I believe. No, easy. The most important is results dot hand landmark. This contains the landmarks for each detected hand. For every detected hand, nature pipe covers 21 landmarks. I explain this right. One hand, 21 mark, and two hands up to 42 landmarks. Okay, the 21 landmarks. The landmarks represent anatomical points on the hand. So I believe this is suggested or chosen by the model itself, not by the robot. For by default, I believe this is how it sets itself up. 0 is always the least. Yeah, I can't recall the understanding, but that's right. 0 is always the least. Then 1 to 4 is the thumb. Then 5 to 8 is the index. Then you can see, sorry. See, I said 0 is the least. 1 to 4 is the thumb. 5 to 8 is the index. The middle is 9 to 12. The ring is 13 to 16, and the pinky is 17 to 20. So you just set that with this in mind, but you are not going to like map it yourself. OpenCV maps that you need to actually explain to it how it's going to map it. Like, I don't know whether you could use more than 21 or less than 21. We'll see. So, for example, the wrist, thumb, CMC, tip. Okay. There are many fingers follows the same geometric structure. The landmarks are extremely useful because they turn a visual hand into numerical data. Instead of saying there is a hand somewhere in this image, we get wrist XYZ, thumb tip XYZ, and index tip XYZ. That is what allows us to build things such as gesture recognition. Okay. So basically, this for hand markers result this. So it's going to map this out, X and Y. Okay, let me just skip this and go to the connection. So these connections are really important. Why? Because later on from this connection, we can be like, if you recognize that 1 and 8 are touching each other, you can do a gesture recognition, like for example, virtual mouse control, or sign language recognition, or finger counting, or So that's why these connections are really important. But I don't know whether you increase, if you use more than 22 models, we'll find out. So landmark coordinates. Each landmark contains an x coordinate, y, and z. So the x and y coordinates are normalized. Wow. So instead of x having the range of 50 pixels and y having 20 pixels, major generally gives 0.42 and 0.42. Why do? The normalized coordinate system is approximately left, right, 0, 1, top, bottom, 1. So this is number representation independent of the camera resolution. Okay. Still hard to understand what they mean there. Still hard to understand what the number coordinate there. Let's converting normalized coordinates to pixels. Oh, okay. So this is interesting because now although it's able to get the locations, remember it's getting it from an image point, so it has a grid where it has the x, y, and z. But I don't know how to z. It has x, y, and z. And from there, from that frame, like if I just stay still, it knows that it is at this position, it's at this particular point which is extrapolated from the x, y, and z graph or coordinates of things. But now, how to interpret it back into pixels? I remember pixels are part of what makes a frame. So remember to send back the frame and send back the video. You need to send on the pixel because the video is operating in pixel level, coordinate level, numbers. Now I'm not really like to say coordinate levels. So we need to get the frame dimensions, height and width, then convert. Oh no, we need to get like the base. The base, more or less, yeah. The dimension of the frame. Then we're going to convert the coordinates now into pixels. So that's what we'll have it here for landmarks, int landmark.x times width in order to get which position on the width of the frame, which position that x component is and which position the y component is in order to get the exact pinpoint of where that pixel will be. It's just a pixel, but like 100 of those now will be coordinates, or on those pixels that now we converted. So therefore, normalized coordinates multiplied by image dimension, or multiplied by image dimension to see how big or small image should be, and pixel coordinates, so that to place back the frames that he has obtained from the course, you need to place it back now into the video, into the frame, and then OpenCV will just draw it back. All this is happening in 100 milliseconds, 1000 milliseconds. So if you put it, if you're able to view it in 1000 milliseconds, you see how fascinating as I don't want to say slow, but how can I say, like the computer will go step by step doing each of these steps. For now, it's just super fast, and you don't believe that he's just doing it out of magic. It is no magic, just that he's doing it at a time rate where it is really impossible for the human eye to even conceptualize. I find it amazing. So drawing landmarks, OpenCV draws each landmark using circle, frame, that is a frame that is getting now to draw the circle based on the x and y coordinate. Okay, this one is for the color of the circle, this 5 negative one there. So is it the image, is the center, okay, x and y is the center. Okay, and radius of the circle, frame, that's the image to draw, the center of the circle, x and y. That is where the landmark will point in the place where x and y coordinates, so where the frame starts before where the circle frame is assigned to. And now this guy is the radius, like from the radius, the area also, yes, the area also, the area also. And the color, this is red line. Is that going to be a BG? No, it's green, yes. It's BG, so G. So that's green. And the color CV. Yep, that's it. Green. The main thing is negative 1 means means fill the circle. Okay, so drawing hand connections. Okay, the landmarks themselves are only points. Okay, I get it. So you don't really need to define these guys, they are already defined. These guys are already defined, so you just know that they're there, and therefore at least you know that you're working with 21, only 21. Sorry about that. So now we're going to connect, we're going over to the connection on the landmarks. Twist them also, but just from the way they are here, it's actually very let's say the explanatory. The landmarks themselves are only points to visualize the skeleton of the hand. We connect them with lines. For example, means 0 to 1, 1 to 2. That's easy to understand. Which creates a thumb. The same principle is used for the other fingers. So I say you just copy and paste these, because formally with this will cause nothing physically. You can still like interchange it and use I think it's 17 to 20. You can still use 17 to 20 as your thumb, and then 0 to 1, like 0 to 1, and then 2 to 4. So you just personal preference, but just go with the default. Why not? Drawing lines. Okay. OpenCV now. So although we have set in the connection, we now need to actually draw lines based on these connections. So start for index, for start index and index in connections. So all of these are indexes, and they will be also changed to pixels by the way. So start point. So this follow is going to be used to draw the lines. So these are them. After we get them, okay. So you can see here again, we'll get the start index and end index. So something is set to start and then is set to end. Okay, so these hand markers. So in place of 0 and 1 is going to now return the x coordinates and the y coordinate. I believe it's just going to, yes, the x and y coordinates for point 0. Let's take an example where as we run this, the first one will be 0 and 1, right? So it's going to return here 0. Start index and 1 and the end index, right? So over here now is going to return the x and y coordinates for 0 and the x and y coordinates for 1. resolution means 2 pixels. Okay. Finally display the result. So finally cv2.image show media hand tracking frame. So what I need, the first argument is the window title. Okay, so you can do without it. And the second is the image display. The image is being displayed. The image being displayed is the original webcam frame with the media by landmarks drawn over it. Okay. So OpenCV is just there to like record and send the frames to media by. Media by is just all of the detection and whatnot, so computer vision basically via models and also the vision, or let's say interpreter or middleman interpreter between the interpreter itself and the models, and it's going to send back the outputs and display to OpenCV. Now the remaining part of the code, which is this guy, is just there to exit whenever you press the kill command. So it waits approximately 1 millisecond for keyboard input while allowing OpenCV to process windows. So before the loop loops back, it's going to come to this point here. It's going to wait 1 millisecond within that. And if kill was ever pressed, it's going to exit. If not, it goes back to the loop. So the expression order kill converts the character kill into numerical representation. Press kill, break, exit loop. Okay. And whenever you break and exit the loop, it releases the camera, because all these are indented. You see the error, and these are indentation. So whatever is out of the indentation will mean that we're broken out of the loop. So first you're not broken out of the loop, it's going to go right back. We're never going to reduce unless we break out of the loop. And the way to break out of the loop is to either force in the execution, turn off the computer, or press Q. So once you press Q, it's going to do this cap release and destroy all windows. So what this cap release does is releases the webcam. It's important because otherwise another application will not be able to access the camera. You can explain that in the beginning. Let's go. Closing OpenCV window. So you're going to close the OpenCV window like you saw there. So why modern media pipe looks different? That's interesting. Older tutorials commonly use import media pipe as MP and uses MP hands, MP solutions hands, followed by these, and then this not by play, that's like 5 years ago. I was watching a tutorial, like I said again. Immediately I started the tutorial, I got this. The compiler was not even understanding what's happening. That's why I actually realized, oh, surely the package is updated, and surely were. Surely were updated. So let me put this back here. Oops. Where are we? This way here. New attacks. Okay, we just explained the model. Let's see one more thing. So the home API which is MP solutions, and so the hands are running the new model API. Just goes way more. It makes use of models and running mode and configuration. All of these are interpreted by vision. All of these has been using tasks, which means that other things again, not just tasks. That's interesting. The model drill approach makes use of model execution configuration. So complete tutorials. So key concepts. I believe if you learn anything coming down, key concepts is anything. What? Not bad. Or we can then possibly did extreme. Because it's just been a lot getting from old tutorial, moving to a new tutorial, moving to new research on how to make an old hand gesture system work. Got that working. I guess the next video we're going to do finger counting. So it's a little bit nice. It's a little bit 1 hour. Let's see. How long has it been? Just an hour. So maybe we should be able to do something. Finger counting, gesture recognition, virtual mouse. So the important transition is from detecting a hand to understanding what the hand is doing. Okay, so that's the end of it with me. So what should we go next with? Computer, human computer interaction, drawing in the air, volume, and virtual mouse. I'm really eager to do a virtual mouse But let's just see what the tutorial had for us next. Let me see. First one was hand tracking. Then it's another hand tracking module again. I don't know why. Pose estimation, face detection, face measure, finger counter, personal trainer. Okay, virtual mouse was literally the last one. Why is virtual mouse the last one? Let's see. Requirements for virtual mouse. Let's see what we need to create this virtual mouse. Video mostly foundation, Python package. Yep. Okay. Oh no. Inside your existing VM, you need to install this. I already have this and this, so it's just to install this and this. Or we're going to use numpy. We need to add this and this. Then check if it is okay. So while auto Kafka user interface controls the actual mouse cursor and clicks. Okay. Helps to coordinate calculations and instances. Webcam provides the hand image and the model that detects the hand. Yep. Yeah, but so also position is operated by this to move the mouse, while finger distance, I think this is when numpy does a finger distance for estimation, gesture logic, click and drag. Which numbers we use? Most important ones are the wrist, thumb tip, index tip, middle finger tip. Okay. So a simple design could be index finger tip. So like index is index. There's a cursor movement. Index plus thumb. I think left click, and then index plus middle, right click, and then index middle. This guy, this movement. I prefer the two fingers. Yeah. Index and middle line. So you just move up and then move down. Yep. Linux main consideration, because you're using Linux main, needs access. Okay. I'll try and build this and then I'll explain what went wrong right. Let's keep going. I'm going to off my mic. So catch you in a few minutes, I guess.